Good morning, everyone. Our group will be presenting about ratio tests. But first, these are the terms we need to define before moving forward.
First, we have convergent. A series is convergent if the sequence of its partial sums tend to a limit. According to Kant 2013, if the partial sums of the series tend to a specific number, then it is convergent.
Absolutely convergent. According to Khan Academy, the series is absolutely convergent, means a series will converge even when you take the absolute value of each term.
Note that if the series is absolutely convergent, then it is convergent. But when a series is convergent, it is not always absolutely convergent.
Divergent. If the sequence of partial sums is a divergent sequence where a limit doesn't exist, then the series is also called divergent. That is according to Dawkins 2021.
Inconclusive. According to Stewart 2016, if the test is inconclusive, no conclusion can be drawn about the convergence or divergence of the series.
Ratio test. According to Weisstein, it is first published by Jean-Laurent D'Alembert and also called the Cauchy ratio test or D'Alembert ratio test. This test is used to determine the convergence or divergence of infinite series which contains an exponential or a factorial.
We have presented terms that are associated with ratio test. This time, we'll be presenting the ratio test conditions. 1. If the limit of the absolute value of a sub n plus 1 all over a sub n as n approaches to infinity equals L is less than 1, then the series of the summation of a sub n as n ranges from 1 to infinity is absolutely convergent. If the limit of the absolute value of a sub n plus 1 all over a sub n as n approaches to infinity equals L is greater than 1, or the limit of the absolute value of a sub n plus 1 all over a sub n as n approaches to infinity equals infinity, then the series of the summation of a sub n as n ranges from 1 to infinity is divergent. If the limit of the absolute value of a sub n plus 1 all over a sub n as n approaches to infinity is equal to 1, the ratio test is inconclusive. That is, no conclusion can be drawn from the convergence or divergence of the summation of a sub n.
May I present to you an example of an application of a ratio test. First, we let a sub n be equal to 2 raised to n plus n cubed all over 3 raised to n. At this point, we substitute the value of n to n plus 1. Then, a sub n plus 1 be equal to 2 raised to n plus 1 plus, open and close parentheses, n plus 1 cubed all over 3 raised to n plus 1. So, a sub n plus 1 multiplied to its reciprocal, which is 1 divided by a sub n, be equal to 2 raised to n plus 1 plus, open and close parentheses, n plus 1 cube all over 3 raised to n plus 1 multiplied to its reciprocal, which is 3 raised to n all over 2 raised to n plus n cube. We come now to the answer 2 raised to n plus 1 cube all over 2n plus n cube multiplied to its LCM, which is 1/3. Next step, we have to divide the top and the bottom by 2 raised to n plus 1. Then, equal to 1/3, open and close bracket, 1 plus n plus 1 cube, divided by 2 raised to n plus 1 all over 1/2 plus n cube, divided by 2 raised to n plus 1, where n plus 1 cube divided by 2n plus 1 equal to 0, and n cube divided by 2 raised to n plus 1 is equal to 0. As approaches to infinity, we get the limit 2/3. Hence, the series 2 raised to n plus n cube all over 3 raised to n as n ranges from 1 to infinity converges. And that is it for our discussion for today. The ratio test. Thank you.